Hello students, my topic is blind search, which is also known as uninformed search. As the name suggests, in this only the initial state and the final state is given and no other information about the nodes are provided. So we have to expand the initial node and we have to generate the successor functions and we have to distinguish between the goal states and the non-goal states. Now we will see the implementation of this blind search, which is DFS. DFS is the depth first search, which works on the concepts of the blind search. In this also no information about the nodes are provided, only the initial node and the final node is given. Now let's see an example. This is a binary search tree and we have this A, this is initial state, and this G, this is a goal state, and only this information, this initial state and goal state is provided and no other information is provided. Now how this DFS, this is depth first search, works. First we have this initial node. We will check for this node if this node is empty. No. This node has successor. Yes. So we will generate all the successors of this node. This is B, C and D. And we check, then we remove this node from the list. Now we will check for this B. In this binary search tree, you already know that we work towards the left hand side of the node. So this B, we will expand, we will check for this B node if B is empty, no. If B has successor, yes. So all the successors of B are E and F. Again from the binary rule, we move towards the E node. We check for the, we again check for the algorithm if this E is empty, no, yes. And if E is goal, no. So we again backtrack and we reach the node B. We again look for the children which is F and we check if this is empty, yes. If it has many successor, no, then we again backtrack. All the successors of this B are executed. We again move towards A node and then we go towards the C node. Now this C node is again expanded. If C is goal, no. If C has successor, yes. So this we reach towards a G node, that is goal node. If G is equal to goal, yes, we have already reached the goal node. So we will terminate our search with success. Now for this algorithm of DFS, first you put node on start list first. If A equal to empty or if A equal to goal, then terminate search. Third, remove A and generate all successors. Fourth, go to step 2. Fifth, exit. So these are the steps which are followed for the DFS. Now complexity. There are basically two types of complexity: time complexity and space complexity. Time complexity gives the amount of time required to reach the goal node, and space complexity requires the memory needed to reach the goal node. And this complexity is the parameter to decide whether any search is good or not. Thank you.